Hello, this is Jack Jackson. In this video, I'm going to be going over an article that I published in the winter 2012 edition of the Arkansas Council of Teachers of Mathematics newsletter on defining and interpreting quartiles. One of the most basic and useful sets of statistics for describing a set of data is the five-number summary known as the quartiles. And these five numbers are measures of relative standing, which also include the second most commonly used measure of central tendency, the median, and can easily be used to compute two standard measures of variability as well, the range and the interquartile range. They are visually represented on a box and whiskers plot, or just a box plot. And so these concepts are introduced early on in statistics. So in this paper, in this video, we're going to be talking about the definitions and interpretations of the quartiles. There's universal agreement on the definitions and the ways of computing the quartiles Q0, the minimum, Q2, the median, and Q4, the maximum. However, there's not universal agreement on the definition of the lower and upper quartiles, Q1 and Q3. And this lack of a consistent definition can become a problem whenever someone is trying to use one method and they think they're trying to use one method, and maybe they pick up some technology or someone else's technique to do the other method. Now, so I'm going to talk a little bit about several different methods of computing Q1 and Q3 and what they actually are trying to do. Now, the big news is, in one hand, it really doesn't matter which one you use. They all give you close to the same value, and it's particularly for a large data set. Usually there's not much difference, and the basic interpretation is basically the same. However, the actual definition is slightly different, and it can be confusing if you're going around picking up different ones. Now, in my classes, basically we use the TI-84 method, mainly because my students use TI-84s or other TI calculators in their calculations, and so we just pretty much use that pretty much exclusively. But if you use, for example, Excel and a TI-84, they're going to give you two completely different answers. And for example, Minitab or SPSS is going to give you another completely different answer for Q1 and Q3. So let's first of all remember that what we do is we take our data and put it in order, in increasing order. And we're going to be talking about the rank of the data. So first place, second place, third place, fourth place, for example, in that list. So the lowest one has rank 1, the second lowest one has rank 2, whether or not it's the same value as the one before. So there might be 7 is the lowest one, is rank 1, and maybe you have another 7. Well, that second 7 is rank 2. The highest data value will have rank n, which is a sample size. Now, of course, finding the minimum and the maximum, the lowest and highest ones, are quite easy. So what we want to do is find these other measures, the median and then the first and third quartile. And what we want to do is roughly divide each of the data parts into fourths. Okay, and the roughly is really the content of this particular talk, because in this paper, because we can see that what we really want is we want the median, for example, to be a data value which divides the data set into two equal halves. And actually you can't always do exactly that. Sometimes you can get a data value, but it doesn't necessarily divide it into equal halves, and sometimes you get a divided in equal halves, but it's not necessarily a data value. But at least approximately that's what happens. And we want basically the same thing for the others. So again, the minimum and maximum are easy. Let's review how we compute the median. So the median, we put our data in our ranked list, put it in order, lowest to highest, and then you find the n+1/2 rank data value. So if n is an odd number, n+1/2 will be a whole number, and there'll be a 1 in that position. For example, if there are 11 data points, 11 plus 1 is 12, divided by 2 is 6. So the sixth one from the bottom will also be the sixth one from the top, and that's the median. Okay, so in this sense, the median is the middle, so it's a measure of central tendency, but it's definitely also a measure of relative standing because approximately half of the data is below it. Now, actually, it's not exactly half below it. It's actually n minus 1 over 2n is the proportion of data that is below the data, and n plus 1 over 2n is the proportion that's above, that has a higher rank than the data, than the median. So n plus 1, n minus 1 over 2n is the proportion of data that's a lower rank than the median. And if you say lower than or equal to the rank of the median, it's n plus 1 over 2n. Now, both of these fractions are approximately half, but not exactly a half. As n approaches infinity, these both approach a half. So the bigger the data set, the closer you actually get to a true 1/2 of the data. But notice that if n is odd, the median must actually be one of the data values. On the other hand, if n is even, okay, then when we use the formula n plus 1 over 2, which is n over 2 plus a half, you get something plus a half, a whole number plus a half. So you get halfway between two whole numbers. And so it says we want it, so for example, let's say the data set has 40 things in it. 40 plus 1 over 2 is 40 over 2 plus a half is 20 and a half, 20.5. So that tells you that we want something between the 20th data point and the 21st, actually halfway between, and that's how we compute the median. We just take the one with rank n over 2, the 20th one, and the one with rank n over 2 plus 1, in this case the 21st one, and just average those two. So in other words, add them up and divide by 2. Find the mean of those two, and that gives you a data value that's halfway between those 2 points that are tied for the middle in rank. And then in this case, you'll get exactly half of the data will be less than the median, at least the rank of it will be less than the median, and the rank of half of it will be above the median. Okay? And we get so half of the data has a higher rank than the median would have, and half of the data has a lower rank than the median would have. But the median may or may not, unless these two are the two things that are tied in the middle are the same data value, the median then will not be an actual data value. Okay? So we approximately, but not exactly, get what we want to accomplish with this definition. We want a data value where half the data is lower rank and half is higher rank. We almost get that with the median, but not quite. We approximately get that. Well, we have the same kind of problem when we have when we try to find Q1 and Q3. Okay, and it turns out there are multiple methods to working this out. And to illustrate that, I have some data sets here. And the data sets here's one data set here, which has 13 elements or 13 data points. Here's one with 14, here's one with 15, and here's another data set with 16. We'll call those data sets 1, 2, 3, and 4. And notice that when you divide by 4, this first one, divide the sample size by 4, the first one has remainder 1, remainder 2, remainder 3, and then remainder 0. And that's going to be kind of important because those are kind of the four cases. If n is 1 more than a multiple of 4, 2 more than a multiple of 4, 3 more than a multiple of 4, or actually is a multiple of 4, those are sort of the four cases. Now, there are multiple ways that we could use it. I'm going to describe 6 of them right here. What the TI calculator does is this. Q1 is the median of the lower half, and Q3 is the median of the upper half, but we do not count the median as the part of either half. Okay, so let's just see if we can kind of do that here. With 13 data points, the 7th one will be right in the middle, so that we have 6 above it and 6 below it, so that's the median. So then the lower half is counted to just be these 6 numbers, and we find the median there, which would be halfway between 16 and 24. And the upper half of the data would be here. We do not count the 48, and we find the median there. So in the even case, for example here, the median is going to be halfway between the 7th and the 8th data point, so halfway between 48 and 56. So this time the lower half is here, and the upper half is here. And then you find the median of the lower half for Q1 and median of the upper half for Q3. Pretty straightforward. Tukey's method is very similar, except, in fact, it's exactly the same as the TI calculator method when it's an even number. So in Tukey's method, we would take the even set here. We would take the lower half like this, find the median. That would be Q1. Take the upper half, which is right here, and take the median here. But when it's an odd number of data points like this, remember this was the median right here, the lower half, when we did the TI-84, the lower half didn't include the median, and we found the Q1 by finding the median of that lower half. Whereas Tukey's method, we include the median in that lower half. When we find the median of the lower half, that's going to be Q1. And similarly, we include the median in the upper half in Tukey's method by, and then we find the median of the upper half. Now, the next three methods really take into account this formula for rank. Now remember, the formula for the rank in the median case, it's going to be in the n+1/2 position, counting, okay, n+1/2 position counting from the bottom. If that is a whole number, then that's the right position. If that is in between, then you interpolate by just averaging the two. So once again, to find the median in the odd case, we take n+1/2. 13 plus 1/2 is 14/2 is 7. We take the 7th one in the list, and that should be the 7th from either the bottom or the top. When you had an even number like 14, 14 plus 1/2 is 15 halves, which is 7.5, which means we're between the 7th and 8th one. Where between? Exactly halfway between. So we just add those up and divide by 2. We do something similar using the Minitab or SPSS. If you ask it to find Q1, we do n+1/4, and that's the rank of the lower one. So let's figure that out just a second. n+1/4. So what you do here is, let's say, well, n+1/4, when you're dividing by 4, there are 4 possibilities for the remainder, 1, 2, 3, or 4. And so if that's a whole number, in the case of 16 here data points, no, in the case of 15 data points, 15 plus 1 is 16 divided by 4 is 4. You just take the 4th one. 1, 2, 3, 4. It'd be 16. Okay? But what if it's not? Okay, so notice that, so what we do here is we interpolate linearly. So for example, if we have 13 data points, 13 plus 1 is 14 divided by 4 is 6.5. Let's see, is that right? No. 13 plus 1 is 14/4. 14/4 is 7/2, which is 3.5. So what we do is we go halfway between 3 and 4, which we just add those up, divide by 2. Okay? Yeah, however, if there are 14, let's see what that does. 14 plus 1 is 15/4. 15/4, let's see, what's that? That's 3 3/4, right? 3 3/4. So it's something between 3 and 4, but not halfway between 3 and 4, the third and the fourth one, not halfway between 16 and 24, but 3/4 of the way from 16 to 24, so closer to 24 than to 16. Similarly, we do 3 times n+1/4, or in other words, 3n plus 3/4 for the rank of the Q3. Okay, so let's try that of just exact for one of these. Let's say 15. Well, 15 plus, well, this is going to be a whole number there. 15 plus 1 is 16 divided by 4 is 4 times 3 is 12. It'll be the 12th one in the list, which would be 80. But if it's between, if it's not in that case, it's one of the other cases where this is a fraction, then we get in between and we again interpolate. So for example, with 16 data points, 16 plus 1 is 17. 3 times 17 divided by 4. How about so let's see what that works out to be. Let's just do it here. 3 times 17 and then divide by 4. 12.75. So 12 3/4. So it's between the 12th and the 13th, between 80 and 88, but it's 3/4 of the way from 80 to 88. Now let's see, from 80 to 88 is a distance of 8, and 3/4 of that is 6. So it's 6 plus the 80, 86 would be the Q3 in that method. Okay? Excel does something similar. Q1 has rank n plus 3 over 4, and Q3 has rank 3n plus 1 over 4. Different, notice, than these, but it uses the same idea. It uses a different formula for finding the rank, okay? But it does it in such a way that you get something between something so that approximately 1/4 is below. And so you interpolate again. Another way to do it is you take n plus 2 over 4 for the rank of the Q1 and 3n plus 2 over 4 for the rank of the top one. And another way that you do it so that you always get something. Okay, so notice that the method 1 and method 2, the TI calculator and the Tukey method, always gets you something that's either a data value or a halfway between. Whereas method 3 and 4 could give you a data value, could give you halfway between, or could give you a 1/4 or 3/4 of the way in between two numbers. So closer to one than the other. Okay, this one also, 3, 4, and 5. Now, method 6, what you do is you take n plus 1 over 4, round it to the nearest natural number to find the rank, and do 3n plus 3 divided by 4 and round that off the natural number to find the rank of Q3. So that way you always get one of the data values in this method. If you take SAS, it actually allows you to do all 4 of these methods, all 6 of these methods. You get to choose which one you want. Okay, so here are here's a dot plot for this particular sample. There weren't any repeats, so it's just dots showing you how they're spread out. And here are the 5-number summary found in the box and whiskers plot for that using all 6 different methods. And if you see, of course, they all agree at the minimum, they all agree at the maximum, they all agree at the median, but they have different values for Q3 and Q3, which is on this side, and Q1, which is right in here. And so they also give you different interquartile ranges. They give you different sizes of the box here. So notice the one with the narrowest box was Tukey's method. The one with the widest box, this one's a wide box down here, method 6, and these are method 3 and 4 are wider here. Okay, in that data set. And then here's another data set. So notice that some of these methods give you the same thing in certain cases. So for the data, for the category 1 data, where it's 1 larger than a multiple of 4, notice that method 1, 2, and 4 are going to agree for Q1, and they're going to agree for Q3 in that particular case, but the others are different. Data set 2, notice that several of them agree for Q1 here and Q3. Methods 1, 2, 5, and 6 agree, but the other 2 are different. Okay, and so forth and so on. You can look at these different ones. If you want, just pause the video and spend some time looking at these things here. So there's some details there that where these get slightly different looking box plots because of the part of the box plot that gives you the Q1 and Q3, because those quartiles are figured out a little bit differently. However, the basic interpretation is the same. Approximately 1/4 of the data is in here, 1/4 is in here, 1/4 here, and 1/4 here. But again, those things are approximations. Now, depending on which method used and the number of points in the data set, the rank of Q1 can be as low as n over 4 and as high as n plus 3 over 4. And the proportion of data with a lower rank than the rank used to compute Q1 could be as low as n minus 4 over 4n, or as high as n plus 3 over 4n. And the rank of Q3 can be as low as 3n plus 1 over 4, and as high as 3n plus 4 over 4. Okay, now, one thing that you'll notice, though, is that these fractions, as n gets bigger and bigger, all these fractions for that are at or below Q1, they all approach 1/4. And so the bigger the data set, the closer that gets to actually being equal to 1/4. And all of them for the fraction below the Q3, all those fractions here, this one right here, and this one right here, and this one right here, these, that should have an n there. Those should all have 4. Those should all have n's there. No, they don't either. Those are how many data points. So to divide them by n, and you get the proportion. Okay, this one is a proportion, so it should be divided by n. Okay, now, so it is true to say that approximately 1/4 of the data is below Q1. It's also approximately 1/4 is at or below Q1. And approximately 3/4 is below Q3 or at or below Q3. Now, another thing, I've been talking about the number of data points and not when I've been talking about the rank. So even if you talk about the median, when we're talking about this, I'll say the median is a place where so many have lower in that ranked list. If you have ties, particularly at the median, or at any of these places where we break, any of the quartiles, then the actual number of data values that's actually at that point could actually include some in the upper half as well as some in the lower half for the median. So you know, for example, if the median could actually be 0 below it if all the lower half of the data is the same, or it could be as high as a half below it if and that's the most. Okay. So in conclusion, well, what's the conclusion out of all this? Well, this is a lot of technical stuff in this particular video. Most of this you're probably not going to even need to know for any kind of a basic statistics class. But the basic thing that you need to know about this is you need to be aware of what particular method you're using, or your textbook is using, or your technology is using, or your instructor's using for your class if you're taking this as your student in a class. Or if you're a teacher, you need to decide which of these methods you want to use, and be sure you teach that particular method. But then also students and everybody using statistics needs to be aware that there are different methods for doing Q1 and Q3, and they all at least approximately or give you the same thing, but not exactly, and they all have the same basic conclusion and the basic interpretation that regardless of how Q1 is actually defined, approximately half the data goes from the minimum up to Q1, approximately a fourth from Q1 from the minimum to Q1, approximately 1/4 from Q1 to the median, approximately 1/4 from the median to Q3, and approximately 1/4 from Q3 up to the maximum. And so the basic interpretation is the same. Just be aware that there are different methods. A lot of the detail here is not really important. But the main thing is that you do get different methods there, and you can do the basic interpretation of what's going on.